Nomenclature of organic compounds. Organic compounds are chemical compounds having one or more than one carbon covalently bonded to two atoms such as hydrogen, oxygen, nitrogen, chlorine, bromine, etc. These organic compounds have specific set of rules to name them because of their huge abundance in nature. They have some unique and remarkable properties which allows them to exist in such great quantity in our environment. Some of the most important properties are catenation. We will discuss each of the properties later in detail. Hybridization of carbon, having various functional groups, and last but not the least, they exist in various forms such as open chain form, cyclic and bicyclic form. So the first property is catenation. Catenation is a unique property of an element to link with the same element in a series forming long chains. Carbon shows this property because of because if the carbon-carbon bond energy is suitable for the catenation property. This property is also shown little bit by silicon. This property allows organic molecules to have as many as 200 carbon atoms in a single molecule. Hybridization is intermixing of atomic orbitals to form new hybrid orbitals. So what I mean to say is, if there are n different atomic orbitals, they combine to give n exactly same hybrid orbitals. So the first point that needs to be cleared is, number of atomic orbitals is always equal to number of hybrid orbitals. Secondly, all of these hybrid orbitals are exactly same in shape and size, stability and energy. But different from the component atomic orbitals. The theory of hybridization is explained as that atoms cannot directly combine to form chemical bonds with these atomic orbitals because quantum mechanically it is explained that lowest energy is obtained when all the bonds formed are identical. And as these atomic orbitals are not identical, they can't combine to give identical bonds. So hybridization is necessary as all of these hybrid orbitals are exactly same. They form exactly same bond, giving the lowest energy to the molecule. So to study hybridization of carbon molecules in detail, first let's see its electronic configuration. So atomic number of carbon is 6, and ground state electronic configuration of carbon is as following. This is 1s, this is 2s, this is 2p. So filling the electrons with off-bow principle 1, 2, 3 and 4, 5 and 6. So in ground state, carbon has two unpaired electrons, so it can form two bonds in ground state. Now let's see about its excited state. So what exactly happens in excited state is, because of this less energy gap between 2s and 2p orbital, one electron jumps from s orbital to this p orbit, and the energy over here is compensated by the energy formed in bond making. So here is the electronic configuration of excited carbon atom. 1s, the electron from 1s can never jump outside because it's the inner shell which almost remains isolated, and the energy required for one electron from 1s to jump to the outer orbital cannot be compensated by the bond formed. So now filling the electrons, this is 1s. One electron from s jumped to the p, 2s and 2p. So now, in excited state, carbon has 4 unpaired electrons, so it can form 4 bonds. There are 3 different hybridization possible for carbon atom. First is sp3, where 1s and 3 orbitals participate in making a hybrid orbital and they result in making 4 sp3 hybrid orbitals. So 4 sigma bond is made by carbon atom and the shape looks like something like this. This angle is 109.5 degrees and the geometry is known as tetrahedron. Second is sp2 hybridization, where 1s orbital and 2p orbitals combine to make 3 sp2 hybrid orbitals. This angle is 120 degree. This is a planar structure and known as trigonal planar geometry. Third is sp. sp hybridization results from combination of 1s and 1p orbital and it results in formation of 2 sigma bonds. This angle is 180 degree and the geometry is linear. The other 2p orbitals participate in making pi bonds. The third very important property of organic molecules which allows them to exist in such a huge number is to have various type of functional groups. So let's take an example of CH4. CH4 is an organic molecule which is just named like any other inorganic molecule. For example, HCl. HCl is an inorganic molecule and is named as hydrochloric acid. NaCl is another inorganic molecule and is named as rock salt. In the similar way, this organic molecule CH4 is also named as methane. So, if I replace one hydrogen of CH4 with X, where X can be an atom, atoms such as fluorine, chlorine, bromine, or X can be a group of atoms like OH, the hydroxyl group, or can be COOH, that is the carboxylic acid group. So, this group, this X, decides the chemical properties of the molecule and hence it's known as the functional group of the organic molecule. So, as it is very clear that there are various different combinations possible for this X. So, it overall increases the possible variety of organic molecules and hence increases the abundance of organic molecules around us. The fourth very important property of organic molecules is that they exist in various different forms such as open chain form, cyclic form and bicyclic form. This is the representation of open chain form. This is the representation of cyclic form. This is the representation of bicyclic form. A part of existing in different forms, there is one more variety possible that they exist with different hybridization, such as some carbons can have sp2 hybridization. Like in this case, these two carbons are sp2 hybridized. Another possibility is there can be sp3 hybridized carbon. These two carbons are sp3 hybridized, and one more variety is possible that they can have functional group attached to them. These Y and X are functional groups. So you can imagine how much variety is possible. Like there is just no wonder why around us there are trillions of organic molecules present. So like methane, which is a simple organic molecule, its name can be remembered, like it's named as methane. But since there is a lot of variety possible in another organic molecules, we cannot remember each and everyone's common name. So hence, it's very important to have a special set of rules to remember all of these molecules and to identify and to study their properties easily. Hence, nomenclature is a very important part of organic chemistry.